go. So let's do attendance. Please tell me that you're here. And then we shall begin. Remind me to release this extra credit as well today, in case I forget. But today is a programming day, so let's open up idle. Get it ready. We are ready to finally make our own functions. This is a great culmination of all the stuff that we've learned. I'm excited. So we're going to learn how to make our own functions today. But first I want to talk about looping just a little bit more. There's a new kind of loop, and then we'll get into functions. Okay? So I'm going to teach you a different kind of loop. We learned about the while loop in Python. I'm going to teach you one called the for loop. And technically, you never have to use a for loop if you don't want to. It is equivalent in expressive power, equivalent in power to a while loop. It gives you nothing new, but it makes some problems easier to think about. So that's why I'm going to teach it to you, and you'll grow to prefer it in certain cases. Okay? Because I do too. So let's learn what a for loop is. What does it do? A for loop in Python iterates through things that are iterable. So remember that word iterate, it just means to go through something. And some things in Python are iterable, capable of being gone through, I guess. One very nice thing that we already know is a list. And a list is iterable, right? We have a list L equals, let's just say it holds 4, 5, and 6. There we go, 4, 5, and 6. And it has indices, right? Those live at indices 0, 1, and 2. You can go through a list, right? And that makes sense to want to do that, to want to visit every element and do something with it, like to sum them together or something like that. That is nice to have. So, yeah, think of anything that is iterable kind of like a list. That will be a good enough assumption for this class. All right? So, I have no idea why this font looks like that, but I guess it's fine. There are some other iterable things. There are also things called ranges, and I want to show those to you too. So a list is iterable, like 1, 2, 3, you can go through it. You can also go through a range of numbers. So there's a function called range in Python that essentially makes a list holding some numbers that we usually care about. So I can say range of 10, and sadly that doesn't really tell me anything, it just prints back out range, but I can convert the range to a list. And here is what it's really making. Range of 10 makes a list from 0 to 9. That's pretty useful, right? We usually like to go through numbers like that. We want to go through all the numbers between 0 and 9, 0 and 99, things like that. So this is a built-in function called range in Python. You don't have to import anything. And it always gives you a list that's one less, goes up to one less than the ending value. So you can say range of ending value. That will give you 0 up until that ending value minus 1. Or you can say range with a starting value and an ending value, and that will give you a list, if you convert it to 1 at least, between the starting value and 1 minus the ending value. So if you want all the numbers between 1 and 10, you really have to say, hey, I want a range between 1 and 11. That's just the way it works. I don't like it either, but we'll get used to it. So range, very quickly, is a function that gives you back numbers that you usually want to go through, right? You like to go through numbers in order. Let's add all the numbers between 1 and 10. Let's just sum all the numbers in the range between 1 and 11. Something like that. So I guess moral of the story is if you want the numbers 1 to 10, just use range 1, 11. There's always 1 less than that ending value. And if you want all the numbers between like 0 to something, 0 to 100, then you ask for the range of 101, the default starting value. If you don't give it, it's just 0. Okay? So those are ranges. And let me teach you how to use a for loop now, how to iterate through things. Okay? So here's what it looks like. So instead of while, you say for, and then you give it the name of a variable. I'll call it x or something. So for x in, you say the word in, and then right here is where you put your iterable thing. Okay? You can give it a range, you can give it a list, like I could say L here. Anything that's iterable can go there. And then you tab over as usual, and then you give your body what you want to do. Body goes here. And the way that a for loop works is it goes through this list L from left to right, or this range from left to right, this iterable thing, and it lets X have a chance at being every element of it. So it's going to run the body each time on 4, 5, and 6, for example, and let X be the first time 4, the second time 5, the third time 6, because it's going through and letting X be all of those values. It's letting it range over the list L, that iterable thing. Okay? Are there any questions about that? That was a lot of words. Before I go to code and show you some cool stuff, it should make a bit more sense with an example, I think. So, let's do that. We are in lecture 23, apparently. Let me go make a folder for that. Lecture 23. And I'll call it forloops.py. So, I can make a list L. That's 1, 2, 3. Or 5, 6, 7. Doesn't really matter. If I want to iterate through the list, I can use a for loop for that. I can say for x in L, and then do stuff. X gets a chance to be every element of L in order. Okay? So if I say print x in the body of this for loop, x gets a chance to be 1, to be 2, to be 3, and it's going to go, and each time it has a new element, it's going to print it. So this will print 1, then 2, then 3. Does that idea make sense to us? Just going through that list. Whee. Does this code make enough sense? Similarly, I could do the same for a range, like for y in some range between 1 and 11. So that's the numbers 1 to 10. Like print y instead. And it's just, you could put any variable name here. Every element gets set to the element of the range in order now. And so it's going to print, let's print a blank line before that so that I can separate what I'm trying to show you. And so this is going to print all the numbers from 1 to 10. Does that make sense? Just let y go and have a chance at being every element of this iterable thing, and then do stuff with y. Okay? That's the idea. And so, one last example. Print a new line. What if we summed all the numbers between 1 and 100? So I'll make a sum variable started at 0, and then iterate through all the numbers between 1 and 100, adding them to the sum each time we visit a new value. So for, let's say, z in range 1 to 101, right, because that is up to 100, it's always one less, then we're going to add sum into z. Or we're going to add z into sum, sorry. Sum is whatever it used to be plus this new value, and it's going to have a chance at being 1, 2, 3, all the way to 100. And once this loop is done, the sum holds the real sum between 1 and 100, all those numbers. So this variable name could be anything, but this, you got to say for, a variable name, in, and then an iterable thing. Okay, and this print is outside of the loop after it's finished. Only then is the sum correct. Okay, so apparently the sum is 5,050. That's a nice number. Any questions about these? These are for loops. They let you just very quickly go through every element of something. And you can think of that something as a list. Are we happy with that? All right. So we are now ready for functions in that case. Let's make our own functions, guys. I'm so excited. So we've done this before in Scratch. We've made our own blocks. That's essentially the same thing. We made some do thing with number block, and it took some n. And whenever we use that block, remember that it, like when we ran this block with some value, it jumped up here and started running all the code inside of this definition. And this n that we're using up here got replaced with whatever was being given, right? So if we passed along 42, now suddenly n is 42, and we're going to do something with that. Or if my number was 55, then that makes n 55 when it jumps up here and runs its code. Okay? Do you remember that? So that's the kind of thing that a function is, essentially. It's some code that we can run multiple times with different values. Okay? So yeah, the equivalent of functions in Scratch were those custom blocks, and they took, in our definition, in our define block, this thing was called a parameter. I don't remember if I said that, but that's the technical term. This is called a parameter. It's replaced with whatever was being given when we actually used the block. And every time you used this custom block, and it jumped up to the code, you gave it a certain value for that parameter, and that was called an argument. We'll say arg for short. Okay? So parameters in the definition, arguments in the use. And I get those terms messed up all the time, so don't worry too much about it. But that is the real fancy stuff. And you know how to use functions in Python already, ones that have been made for you, right? Like you say range of 100. That gives you all the numbers between 0 and 99. This was an argument because you're using the function. Does that make sense? That's all. Same here. It's like, okay, you call a function, you use its name, you put arguments within parentheses, comma separated, and then if the function does something and gives back a value, you can like save that value for later instead of equal to a variable. That's how we call functions in Python. And the only last piece of the puzzle is, how do we define our own? What's the equivalent of this idea in Python? All right. So in order to define a function, here's what we need. We need to name our function like we're giving birth to it. So we need to give it what we want to call it. We have to name it. And then we also need to say what the names of its parameters should be. Like when we jump up here to the definition, we're getting a value. What are we calling that value? Because we need to be able to refer to it and use it. And then, of course, we also need to give the body of the function. We have to say, hey, what happens when we call our function blah? What's going to happen in the body of blah with the parameters, with the arguments that are being given and set into our parameters? Okay? So that is the goal. Any questions before I get to the syntax? This is one of the harder topics, I would say, in this class. Function definitions, at least. They're kind of hard to wrap your mind around, so please stop me at any point. Ask lots of questions. So if we're good, here's how you define a function in Python. You have to say the word def for definition. You say def, and then you give the name of the function, and then all the parameters that you need to use inside the function, separated by commas inside of parentheses. So it's kind of like you're calling it. Kind of like that. So you say def, then the name of your function, and then all of the parameters, p1, comma, p2, as many as you need, dot, 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 and then a closing parenthesis. And so all of these are your parameters. And then that's pretty much it, right? You have to give a colon, as usual, to separate. Okay, here's the start. Here's all of my parameters. And then you give the body, just like if it was an if statement, if it was a loop. Okay, you tab over, you give a body, and that's where you use the parameters that you were given. Somebody gave you some arguments, they got set into those, and then you're doing stuff with them here. Body goes here. Okay? That's essentially the syntax. And then sometime later, and this is the last piece of the puzzle, you're going to use that function. You can use it multiple times, right? That's the whole point. I don't have to call square root just once in my code. I can call it in a million different places. That's the point of a function. I can reuse it. So eventually you're going to say this. You're going to call your own function somewhere. You're going to say funcName. And you're going to give it arguments, right? You're going to give it values to be set into the parameters. You'll be like, I'm going to call my function with 42 and 43. Let's say there were only 2 parameters. That means these are arguments, okay? It's like maybe if your function added them together, it would take these and then give back their sum, for example. But you get to define what you want done with the 2 things that it was given. And here's what happens. Those arguments are being set into the values of the parameters. So the 42 for this particular use is being set into P1 when it jumps up to the definition and tries to run the function. The 43 is going to be set into P2 when it jumps up to the definition and runs the function. Because that's the whole point of a function, right? We call it, here's what it means to do that function's work. We run the body, but we were given some stuff to work with. We're going to name those as variables. Those are our parameters. So those arguments, 42 is being set into P1, and 43 is going to be set into P2. Okay? So one last time, the parameters are the names of these variables that you're getting inside of your definition, the ones that you want to use when the function's called. And then the arguments are when you actually call the function, those are the values that you give. It could be variables, but they'll be, it'll just look up the variable name value, the variable's name and get its value out of its box. So you can like pass along x here or something if that's a variable you have. But its value is going to be set into these. Okay? That's the idea. So that's parameters versus values one last time. Okay? So that's some new syntax. Are we good for an example? Are we ready for a simple example with functions? I will take that as a yes. So let's make probably the simplest example I can think of. Let's make a function to print all the numbers from 1 to n, okay, inclusive. Print all the numbers from 1 to n where we're not sure what n is, right? We want to be able to call our function like this. Print from, I don't know, print from 1 to, and then we give like 5 or something. And this is our function, and it's going to go off and it's going to print to the screen 1, 2, 3, 4, 5. Okay? You could maybe call it with 100, and it would print from 1 to 100. That's the whole point. So that's our goal. That's what we would like to write. And so that means we need a parameter, right? Because we need to pass along an argument. Yes? So let's do it. So let's define our function. It's going to be called print from 1 to def print from 1 to, and then we want to use whatever was passed to us, so we need a variable name, okay? We need a parameter name. Let's call it n, all right? Then we give a colon, and then we use it, okay? That's the idea. And so what we'll do with our n is we'll loop from 1 to n, right, between all the values and just print each value as we visit it. And that's pretty much it. So I'll write this body in just a second, but here's what happens when you call this function really, okay? So I call print from 1 to, that's my function that I'm writing. That means it's going to jump to the definition, and it's going to set n to be whatever the parameter, whatever the argument was that was passed to me, n is the parameter's name. So inside of this body, when it gets run, it jumps there, and it sets the parameter values to whatever was passed. So if I'm calling it with 5, that means when we're inside this function, n is a variable, n only exists inside the function, the func, let's say. And so when I start running this code, when I called it with 5, I'm going to have a variable called n that has been set to 5 for me. Python's doing that for me. So I'm passing along the 5. It's being set into n, and I'm using it as a variable. Because I don't know what was passed to me. I just have to use it however it was given. Because I can call this function with 5, 100, a million, whatever values I want. Let's call that number that I get n and work with it. Okay, the same way no matter what I'm given. That's the goal. All right, let's do it. Let's actually code this. Let's see here. Let's just call it functions.py. Let's see if I can just put them all in here. So I need a function. I'm making my print from 1, 2 function. I'm going to call it down here. Print from 1, 2. I'm going to give it 5 to start. And I'll call it with different things later. And then I want to define it. Def print from 1, 2. Here's our name of our parameter. And then, so I get to use n here to print from 1 to n. Okay, that's the goal. So all I have to do is loop through all the numbers for x in range from 1 to n plus 1. Now I can use the range. And this will give me all the values between 1 and n, right? Because it's always 1 less than the ending value. And I can print x. So that should be enough to make it work. And that'll print from 1 to 5 when I call it. And the beauty of a function, if I print any line, I can call it multiple times. Let's print from 1 to 10 this time. And so this is a different call to the function. Again, it's going to jump up here, but it's going to set n, the parameter, to the argument 10 now. And so it's going to be working with n equal to 10. And so it'll range between 1 and 11, and that's why it's going to print the proper values. Okay, so it both can print from 1 to 5 and from 1 to 10. It's our own function. It does different things depending on the value of the parameter, the value of the argument that we pass along that becomes the parameter. So that is our first function. Are there any questions about it? I can call it a million times. I can call it in a loop if I wanted to. It's just like any other library function that we've used. So we're good to move on. Slightly harder example. All right. Because this is a function that's meant to be called by itself, right? On the line by itself. It makes no sense to be like, set the result of this function into a variable called y. That makes no sense at all. Like, what's the answer? 42? I don't know. There is no answer. So let's create a function that gives something back, that does give back an answer that you can set into a variable or do whatever you want with, okay? Because some functions give back results. Other functions, like the one that we just wrote, it just does stuff. It's meant to be called by itself. It just does something and it's done, okay? Other functions give back results, like, for example, the min and max functions in Python. Min, for example, if you called it with 2 and 3, it's going to give back the 2, right? Because that's the minimum of 2 and 3. If you called maximum, the max function on, 2 and 3, it's going to give back the 3 because that's the max value, right? It's going to give something back. And you could do like more computation after the fact, after you've called those, because it's giving results back that will be numbers. You can add together the numbers that are the results of those function calls. Yes? How do we make a function that gives something back? Okay? Because that's what's happening. The min function, for example, when we call it like this, set its result into x, it will give back 2, and we'll have it set x. Okay? Let's talk about that. Do I need a new file? Why not? Let's just keep it all here. So I can say, let's just do it in the REPL right now, actually. That would be easiest. I can say min 2, 3, right? And it gives back the 2, though. I can say x equals min 2, 3. And it will actually set a value into x. It's 2 now. That allows me to do stuff. I can say print min 2, 3 plus 1, because it's going to give back a value. It'll be replaced with what it gives back. So this is essentially going to be 2 plus 1. It'll give back 3. Or it'll print 3, really. Okay? That's the idea. So when you call a function, that call, if it gives something back, it will be replaced with the thing it does give back. Okay? So saying print min 2, 3 plus 1 makes sense because this will become a number eventually. It will be replaced with the number 2. And then it could add it, and that will be itself replaced with the number 3 because that's the result of the addition. And then finally print can go off and print something. Okay? This line, for example, though, makes no sense at all. Does that make sense? Or, again, right? It's the same kind of idea where print is a function that just does something for me. It prints to the screen. I can't use this in a bigger expression. I can't be like print hi mom plus 1. It gives nothing back. I can't assign its result to a variable. It doesn't make sense to do that. Okay? Print blah plus print foo. Let's try all these. Let's see what happens. X equals print hi mom. Well, it does go and print hi mom because that's what print does, but did it give something back to put into X? No. If I say X right now, it just, it doesn't give anything back to me for X. It's saying that nothing is in X right now. If I say print X, it actually holds a special value in Python called none to say exactly this, that print gave nothing back at all. There's a special keyword in Python that means nothing got given back. Okay? And same with this, print blah plus print foo. Again, makes no sense. It's going to print them both. It's going to be like, I need a value. I need a value. Let's try and add those values. But again, nothing is being given back. These special nones are being given back. And it makes no sense to add two nothings together. Okay? So everybody see the difference between a function that just does something like print and a function that gives something back like minimum. That's a key difference. All right. So we'd like to make functions that actually give things back to whoever called us. And to do that, inside the function, there's a special keyword called return. Okay? If you say return this, it'll give it back to whoever called you. So let's use that. Okay? Let's see here. What do I want to make? Yeah, let's do this. That's a good next step, I think. So let's make a sum function, a very easy function. Maybe we could just call it add instead. But here's the simple idea. Our sum function will take two numbers and give back their sum. So if I say sum 2, 3, we want our function to give back 5. So it's just going to add the two arguments that it was given. Very simple function. But the goal is, because it gives back values, we can use it in bigger expressions. We can say sum 2, 3, call our function, and then like multiply that answer by 2. That makes sense to do it because it's going to give back an answer and be replaced with that answer. So that should evaluate to 10 now. Okay, if I do something like that. So that is the meaning of the sum function. And we're going to create it. We're going to give something back with the return keyword. Okay, so let me go off and make this function for us, and then we'll talk about it some more. I also want to talk about a concept called the stack. Okay. Dun, dun, dun. So here we go. So let's make a function called sum. Def sum, and it's going to take two values. I'll just call them x and y. Okay, because I'm eventually going to call it like this, sum 2, 3 or something. Sum 2, 3 times 2. And I can print that answer. All right. So I'm going to take my x and y and compute some answer. Like the thing that I want to give back is x plus y, right? Whatever that is. And to give it back, I say return. Return, and then whatever you put after return is the thing that's being given back. Okay? Okay? I say return x plus y to give something back, to give an answer back. And that is a key difference between this and print from 1, 2. Okay? Oh, why is it not scrolling back over? That's bothering me. There we go. Okay, so I'm going to call this now. Call our sum 2, 3 function. And watch what we get back. We get 10 back. Because it's going to compute the sum of 2 and 3. It's going to jump up here, run the code with x being set to the 2, right? And y being set to the 3 that we passed along. And then it adds them together and makes 5 and gives it back with return. And so that makes this whole thing, this whole call, then get replaced with that answer 5. then we can multiply it by 2, do something with it. That'll make 10. This whole thing will then get replaced with 10, and that's what print sees. Print sees that final 10 value, and that's what it knows to go off and print. Okay? That's a key difference between sum and print from 1 to 2. Like if I were to say this, gosh, what's the best way to do it? If I were to call my print from 1 to function, let's do it up here, print an empty line. Let's say print from 1 to, I don't know, 3, and let's print it. Print a print from 1 to 3. Does that make sense? I'm going to make it make sense in a second. Here's what it does. That's these lines being printed right here. So this call is going to first call this function. That's going to go jump up to our definition from print from 1 to, run it, which is going to print from 1 to 3. This whole thing gives back nothing at all, which is a special value called none in Python. And then that's going to print, like this gets replaced with none, and then it prints none, okay? The function gives back none, or nothing at all. Okay, so it makes no sense to call the print from 1 to function like this. It's printing inside of its body. We don't have to add another one. Okay, we just call it on a line by itself. Whereas for sum, you just call sum on a line by itself. Sum, I don't know, 5, 5. It's not going to print anything. Right? It's just doing the computation. Now maybe let's do something different. Sum 5, 10. So that it's clear that it should have printed 15 or something, right? This just computes 15, but we did nothing with it. It gives back the answer, and we didn't print it or anything. Okay, that's a key difference. This result, or we're not doing anything with this result. So that's another idea. Okay, so that's a lot of concepts. Are there any questions about anything I just did? Anything too weird sounding? Can I re-explain it? All right, so if you didn't quite catch how I said, like, this is going to get replaced with things, we're going to give back values for the next function to use, I want to show you a way to make that easier to think about. Okay? It's called the stack. So first, let me read these bullets, make sure that I have said them word for word, just so that we don't miss anything. So yeah, when you return something from a function like we were doing here, in sum, we gave back an answer to whoever called us. Okay? Oops. When we did that, the call to our function gets replaced with the value that we gave back. So this is getting replaced with 5, and we're allowed to do stuff with that 5 because it's just going to be replaced with it. For all intents and purposes, this call is the number 5. It's going to give it back. Okay? So we can do stuff with the result in a bigger expression. All right? That's the idea. And then when you don't return, there is no result to use. You can only call that function on a line by itself. All right? So let me kind of express the difference. Let me talk about our sum function. So here's what we did down here. Let's say, let's do a simpler version and let's talk about it. Print a new line. So let's just say print sum of 2 and 3. So that's going to just print 5, right? It's going to compute 5 from sum and print out the 5 right here. Let's talk about this particular call now, all right? So I want to draw something called the stack for you, okay? It tells us what functions have been called, which ones are still working on things, and who's giving back things to what, okay? This is not something that you have to memorize or anything like that. It's just very helpful. So it lets us remember like what's going on. It's an example of something called the stack of all the functions that are being run in our program. So when our program begins, we're not running any functions at all, right? So we're just running this code that exists outside of everything. So I'll call that like the outermost code. That's always running, as long as our program is running. Outermost code. And then when we get down to here, let's pretend we're on this line, we need to call print, right? So we have to say something. We're calling print, so we're adding that to our stack of things, our stack of work that needs to be done. Okay, this is a nice way to think about functions and how they're returning. And then what does print need? It needs something to print, right? It needs some number, for example. But we don't have a number to print yet. We have a function call. We have to ask the sum function for an answer before we know what to print. So we have to then call. Print is going to wait on the sum function. Okay? The sum function has been called with 2 and 3. So we jump up here to the definition of the sum function, and x is set to 2 and y is set to 3. We can draw that in our diagram. So we're in the sum function, x is 2, y is 3. This is a helpful little diagram once you understand how it works. But I promise not to test you on it. So now sum is off to the races. It's working, and it gives back the answer 5. Who does it give it back to? It was print that was waiting on it. The person immediately below you on the stack is the person that's getting your value. Okay, so sum gives back the number 5 to print, and now its work is done. Now we're back in print's code. It can actually print the 5 to our screen. There it goes. And now print is done, and we're on to the outermost code, the next line if there is one. ... Okay, so that's kind of how functions are being called and returning on this line. Okay, are there any questions about that concept? Does that clear anything up? Or does it make it a bit more confusing? Because what I'd like to do is show you something like this. Like, why is this doing something really weird? Okay, what's the difference? So let me show this to you. Let me make a different function called sum underscore bad. Okay, so here's another sum function, but it's going to do it wrong. Okay, instead of returning x plus y like it should, let's make our sum bad function not return anything. So this function is incorrect. Instead of returning x plus y to whoever called this, we're just going to print x plus y inside of the function body. So that's kind of right, yeah? It's still adding, and then it's printing out the answer, but it's not giving back the answer, okay? It's just printing. It's not giving back the answer. And that will make all the difference, because watch, if I call this function, I don't know, I guess I need a new line. Let me call sum bad of 2 and 3, and let me, oh gosh, let's try and print that. This will explain what was going on up here now. Print sum bad 2, 3. It's going to print 5 and none. It's going to print both of those. And let me show you why. And then I'll also show you, just for fun, if I multiply this by 2, then I'm really going to get an error. It's not going to work at all. It will print 5 first, though, surprisingly. So this is definitely not good. So let me just show you this way first, and then we'll talk about the way that causes the error too. All right? So I was in my outermost code, minding my business. And I wanted to print something, so I called the print function. Okay? I called the print function. And then the print function was waiting for an answer to print. It doesn't know what to print yet. It needs to call this function first and get back an answer. So print is going to call sum bad for us. Sum bad. And it's going to get as parameter values the argument. So it's going to get 2 and 3, put it in x and y. Sure. It's going to get that 2 and 3 here. And then inside of the body of the sum bad function, it's going to print x plus y. So it's going to print 5 right now before it's done. And now the function's over. It goes back to whoever called it. And it doesn't return anything at all. So in Python, we say that it gives back none, gives back nothing. Okay? And so now that's what print sees. It was waiting on something to print. It got back the answer of none. What? Weird. Okay, so it's essentially me saying print none, please. And so print obeys. It goes off, and it's like, all right, yeah, I gave back an answer of none. That was when I called it up here. So I'm going to print none also. So it prints first the 5, and then none itself. Because that's what print saw. That's what this line saw. equivalent, essentially, print none. That's what it's doing. And it goes and it follows that to the letter, right? Are there any questions about that? Does that make sense why it's doing it? It's a really weird thing. And then now it should make extra sense why that line that caused an error really is not going to work. Because, let's print a new line in between so we can see what this is doing. Sum bad 2, 3, plus, or let's do different numbers, like 4, 5, times 6 or something. If I run this, I'm going to get an error. But first, it's going to print 9. Because I call print, it needs an answer to multiply by 6. So it goes and calls sum bad, which is going to print 9 and give back nothing at all. So that's essentially going to do this now. It's going to be replaced with none again. So it's going to say print none times 6. That's essentially what it's seeing. That whole computation got replaced with nothing at all, and now it's trying to multiply nothing by 6. And that is a runtime error. Makes no sense to do that. Okay? So if you want a value and you want to give back a value, you have to return it. That will do the job correctly. That will actually give back that 10. Okay? And that's the key difference. A function that returns versus a function that just does something, like printing. So that was my long rant about this. It's a very important rant, though. It's a common error when you first learn how to program, the difference between doing something in a function and returning something from a function. Are there any questions? I have more examples. It may be just a case of gotta see a bunch of examples to make it sink in. And that is not a problem. All right, so the next example that I'd like to do is this one. Let's make a function that sums together all of the numbers from 1 to n, okay? Sum all the numbers between 1 and n, and let's do it with a while loop to remember what those are. And here's what it's going to look like, okay? Def sum 2, sum 1, 2, and then give it an n, that's arbitrary. And then we're going to start off a sum variable at 0, like build up the sum with a loop, and then give back that sum, okay? So for example, if I call sum 1, 2 with 5, then it should calculate and give back the answer 1 plus 2 plus 3 plus 4 plus 5, whatever that is. That's, is there an easy way to see this? 9, 10, 15. That'll give back the answer of 15, okay? And all we have to do is calculate the sum with the n that we're given. So here's a good way to do it. Remember how to calculate the sum of a bunch of values from 1 to something else. You can just use a loop. Start I at 1, be like while, let I range between 1 and n, while I is less than or equal to n. Write it like this. Then add into your sum variable that started at 0, sum equals what it used to be, plus this new value of I, and then get ready to add in the next value. I starts at 1, we want to add in 2 next, then 3, then 4. So every time we execute our body, we need to increment I as well. Okay? So that's the calculate the sum bit, and because it's going to give back the sum, we can use our sum1, 2 function, sum 1 to 5, for example, in a larger expression. We can like multiply its result by 3. Because this is going to get replaced, remember, with whatever the value it gives back. So that's like 15. It will give back 15, and then it'll multiply it by 3. And that is correct computation. That's going to compute 45. And then you can use the 45 in some even bigger expression, like involving print. Or more arithmetic. All right? So yeah, this is going to go off, do its work. Sum starts at 0. I starts at 1, and it keeps on adding I into sum. So adds in the 1, makes I 2, adds in the 2, makes it 3, just keeps on putting stuff there. Okay, dot, dot, dot. So that's the goal. Are there any questions about this code before I like write it all at once as one big package? And that's another function that returns something. All right. I think I've made this file a little too big, so let's make a new one. I'll call it sum from sum functions. That's .py. So here's what we'll do. I want to be able to call it like this down here, like use it in some large expression. So print the value of sum 1, 2, sum from 1 to 5 times 3, something like that. And then here's my definition of the sum 1, 2 function. Start sum at 0, then calculate that sum, which we are going to do with a while loop this time. So I equals 1 while I is less than or equal to n. Add into our sum variable, sum equals whatever it was plus I. This is something we already know, right? I equals I plus 1, increment I. And then we're done. We have the sum set to whatever it needs to be set to because the while loop will have stopped. So down here, we're ready to give back the answer. Give back the final sum. So return whatever is in the sum variable. That's what's happening. And so this will get replaced with the 15, multiply it by 3, get 45, and then print can take it from there. It'll take the 45 and print it out. So that's what that code is doing. That's useful. Any questions about this code? It's a slightly bigger example of one that gives back a value again. When we call this function, because it gives back a value, oops, why is that there? Because it gives back a value, it's being replaced with the value that is being given back. All right. If we're doing okay, I have, finally, a question for you. So instead of making this sum 1 to n function that gives back 1 plus 2 plus 3 all the way to n, I would like you to change it up a bit, make a sum all the odd numbers from 1 to n function that gives back 1 plus 3 plus 5 all the way to n. Okay? So for example, if I called sum odd 1, 2, I don't know, 7, it should give back the answer that is 1 plus 3 plus 5 plus 7, which is 12, 13, 14, 15, 16. And you can use that in a larger expression. Okay, so that's what I want you to do now. And you can have this code right here to start with. I think I can get it all on the same screen for you. So take a little bit, take a few minutes to make a function that's very similar to this one, right? But only adds up all the odd numbers between 1 and n, okay? So give that a try and help each other. What do you think should happen if the user calls their sum 1 to odd function with even number of arguments? A couple more minutes to try. Yeah, cool. All right, that's my timer, but does anybody need more time? Want to keep working before I give away the answer? All right, so I want to add the odd numbers and give that back. Let's see what needs to happen. I can mostly take what I did, right? Mostly take what I did. Some odd 1, 2. And, well, what needs to change? Why does this add all the numbers 1, 2, 3 all the way to n? How do I change that to add 1, 3, 5 all the way to n? I think it's going to be okay. So even if I say some odd 1, 2, like 8, there's a way to just keep what I had mostly and just stop the addition when like we get to 1, 3, 5, 7. Like don't try to add 9. Does that make sense? Because again, this will still use an I, so as long as I stays below 8, it's fine. It's just I will never get a chance to be 8 itself. Does that make sense? That's the way that I want to do it. That's probably the easiest way to modify the existing code. So how can I change this? How can I make the next I that I add 3 rather than 2? And the one after that 5 rather than 4? Yeah? What needs to change? Which line? That's right. So this line, you see how it's incrementing I one at a time, 1 by 1? So if I used to be, I don't know, if I used to be 1, this line right now is making it 2, right? It's setting I equal to 2, because that's plus 1 more than it used to be. So we don't want that. We don't want it to become 2 next. We want it to become 3 next. Does that make sense to all of us? So that needs to change to I equals I plus 2. And so now the next time it'll be 3. The time after that will be 5. It gets to range over only the odd numbers. Any questions about that? So just stop before we get to 9. That makes sense. So let's try it. Print some odd 1, 2, 7. Is this all we need to change? Dun, dun, dun. 16 is the answer. Isn't that crazy? So we only need to change a single line, and then that is going to add only the odd numbers. That's really cool. And it's giving back the answer, right? It's giving back an answer that we can use in a bigger expression. Multiply it by 4 or something, or times 2. Something easy. And so that's 32. And also, sum all the odd numbers from 1 to 8 will be the same answer, right? Because the next odd number would have been 9. We're not going to add it in. So those both give back 32. Or they both print 32. That's the idea. So are there any questions of why I only need to change this one line from this to add up all the odd numbers? So this is good to review, I think. All right. So yeah, we needed our I equals I plus 2 line here. That made all the difference. And so I guess the moral of this story is that functions are a really great way to reuse code. It's a nice spot where you can always keep coming back to it, right? You can just keep recalling your function to do that similar thing over and over again with maybe a different value for its argument, your parameter, depending on your point of view. So functions are great for code reuse. Makes your program smaller, so you don't have to duplicate everything. Just make it a function. Keep calling that function, that repetitive thing that you noticed. Okay? That is a nice pattern to make a good program. And for my last slide, I would like to talk about something special. Because now we have functions, we have variables that don't always exist. I want to talk to you about that. So for example, this n, when I call some odd 1 to 7 and 1 to 8, n is being set in this call to 7. And in this other call, n up here is being set to 8. And n only lives for this function. N does not exist outside of this function. It's like this diagram that I was showing you here. Like once sum is done being called, x and y go away because they were special for sum. They were what it needed. It wasn't part of the whole program. So that is a term called a local variable. Okay, so all the variables that we have been making normally before now are called global variables. Everybody's able to access them. Everybody can see them. Everybody can use them. So let me show you that. Just to make it clear. Locals versus globals .py. Here's the idea. I can make an x variable, set it to 42, and this is a global variable. Okay? This is a global variable. Everybody can see it. It lives / is visible. Let's just say visible. It is visible to everybody, even functions. So, like if I have a function called def, I don't know, blah, I can run that function and do stuff with x. I can print x, I don't know, x times 2. Okay? X still exists in here. Okay? That's the idea. So it's allowed to do that. I can, of course, use x outside of everything like I've normally used it. But I can use it inside of functions. And when I call that function, it's going to run this code and actually use the value of x. Okay? That's a global variable. It prints 42 and 84. Okay? So x is visible to everybody, even the functions. So those are the variables we know and love already. You can instead have local variables. Those are variables that are defined inside of functions. Okay? And only the function is able to see that variable. And parameters count as local variables, by the way. Okay? That's the idea. So I can make, inside of my blah function, a y variable, set it to 3, and, I don't know, print y times 2 as well. And that's going to be fine, right? Because y exists inside the function. It's a local variable. And so it's going to print 6 when I call it, of course. But let me try this. Print y. If I try and print y outside of blah, right, or this y was local to the blah function, if I try to, in the outermost code, to print y no longer exists. It lived only for the life of the function. It was local to it, we say. And so printing y makes no sense. It's saying y is not defined. Maybe it used to be inside of a function, but because it's not a global variable, it's not visible anymore. It is not alive, we can say. Okay? So parameters also count as local variables. So here's the kind of idea that went on. I had my outermost code, and I made an x variable, set it to 42, and then I called the blah function that did some stuff. It was, the outermost code was waiting on it, and it itself had a y variable that I set to, what was it, 3? And then it did stuff with y, it printed it out, but the second the blah function is done, it completes and it goes back to the rest of the code, all of this memory goes away. That's the idea. That's what local variables are. They are local to the function that is being called. Okay? They go away. Y no longer exists here. Does that idea make enough sense? So functions give you a place to define new variables and not have them pollute the names of other variables that you might already have. You can reuse names inside of functions, and they are local to just that function. So I could technically make another variable called x in here, and it will be separate from this outer x, which is really weird to think about. Are there any questions about this idea? It's a very subtle one, and it will come up later. I just wanted to show it to you now, so it's less surprising later. Okay? The last thing that I want to say about this is there is a weird thing involving global variables and their use inside of a function. So if I wanted to change x inside of this function, x equals x plus 1, if I wanted to do this, I am technically not allowed to yet. I am trying to change, this should change, right? Changes the global variable called x that exists outside the function. This is technically an error right now, this line, for a reason. I am not allowed to reassign, like I'm not allowed to increment a variable that is global inside of a function unless I'm very explicit about it. Okay, so if I want to make this line work, I have to say I would like to treat x as a global variable and also change it. Okay, if you want to set a global variable inside of a function, you have to say global x, for example, on a line all by itself, just to prove to Python that you know what you're doing and you're not trying to make up a variable that doesn't exist. You're not trying to increment a variable that doesn't exist. You have to say, trust me, I'm doing something and it's going to work. Global x. This is saying I want to modify the global variable x. I'm not making a mistake here. I'm not trying to increment a local variable that doesn't exist. I want to modify a global variable, please, Python. Okay? So you just say this on a line by itself, and then suddenly this is allowed to work. Okay? That's a weird quirk of Python, but I guess without it, it's very prone to errors, like trying to assign a local variable that doesn't yet exist when a global one does exist. So this is all going to work, and this is still an error out here. Okay? So y no longer exists here, and it will give a runtime error. Are there any questions about this code? Why it's doing what it's doing? This is a weird little quirk of the language, but I will show it to you again, and you'll get more experience with it. Are we happy? All right, so Before we go, this is the last slide for these slides. I would like to release your next extra credit assignment. Nope, I'm not currently logged in. Let's maybe do that. Boop. Well, let's try again. So here's your next extra credit assignment, because the current one I assume is due this week, maybe, or it was due. So this one will be due the last day of class, May 13th. Last day of classes, I guess. We don't have a class on the Friday, but that's the idea. And this one is, again, worth up to 5% extra credit. Do it if you need it. Let me zoom in for you. This one is all about Python. So I couldn't really test you on Scratch on the midterm, but I can definitely test you on Python for the final. Because you can type text very easily into Canvas, right? And that's all Python programs are. So prepare for that. I'll talk more about the final when we get closer to it, though. But I think a great thing for you to do is to review Python, okay? To review it and then give your review to your peers so they will love you forever as they're studying for the final, okay? That's the idea. So make a video to help your peers study Python. You can just post a video. You don't have to like edit it in a fancy way. Just record yourself and make it work. But here's what I would like you to do if you want to do this extra credit. So go through one or more examples of these Python concepts that we've been learning. Make it cool. Use like the turtle to show functions or something awesome. And just make a nice, easy, fun to watch video that is creative. The one thing you're not allowed to do is copy anything that I did in lecture. So you can't like go over files that I've written already. You have to make up your own examples, okay? This is extra credit after all. And yeah, as you're going over the stuff that you came up with, just pretend you're giving a lecture, pretend you're me, and demonstrate the stuff that you're going over so that your peers can see those topics again from your perspective. And maybe that will help them learn. That's the idea, okay? So if you want 2.5% extra credit, if you want half of this extra credit, you can make a 15-minute video. And if you want the full 5% extra credit, you can make a 30-minute video, okay? So you don't have to like edit it, just record yourself, start typing, start drawing on Paint or something, and that will be the assignment, okay? So let me know if you have any questions about any of this, but you've been recording yourself for assignments already, so you should be good to go. Are there any questions about this? All right, that's all I got.